In this video, we're going to be talking about how to find the surface area of a prism. First of all, let's describe something called a net. This is one method that you can use to help you find the surface area of any three-dimensional shape. A net is really what happens, or a way that you can describe your shape, when you unfold all of the pieces. So unwrap this shape and let all the sides fall into a two-dimensional surface. So if I take this top and fold it back, take this bottom, fold it down, and then fold apart all three sides here, then I get what's called the net of this prism. So notice that the height of my prism is that length now in my net. A was the bottom of this triangle, and also the left side, the bottom of the rectangle and also the left side of the triangle. So these two measurements would be A. B was attached to our triangle still when we unfolded that triangle, dropped it below. So B is the bottom of the rectangle length still. And C is the bottom of the rectangle on the right side, but also the right side of the triangle. So C could represent either of those two measures. It's a little bit hard right now with these letters instead of number values or lengths. So we'll get to an example when we actually use some lengths here in a second. We got a few more vocab words to talk about, and that's going to lead us into the formula for finding surface area. So it's important that we understand what these pieces are. Faces are the two-dimensional shapes. So for example, this rectangle, well, all of these rectangles and these two triangles are all faces. But there's a difference between our faces. The base shape in a three-dimensional figure is going to be called the base face. So hopefully remember from our volume section that if it's a triangular three-dimensional figure, well, then the triangle is the base shape. So we have two base faces, one on top, one on the bottom. The lateral faces are the other faces that are not the base faces. So it's not a triangle, then it must be a lateral face. So that makes these three rectangles the lateral faces. Edges, we don't have to complicate things. That would just be the ends of our shape here, where two shapes come together. That's an edge. Be careful when labeling edges. I mean, they're not super important to identify, but if you label the net, all the edges on the net, you're probably going to come up with some extra edges that aren't necessarily edges of the three-dimensional figure that it started with, because some of those edges might be counted twice. So if you were to label the net, I think you might come up with 10 edges. Whereas if we go back to the original figure here and we count just the edges there, we're actually going to come up with 9. So on top, on this triangle, we got 3 edges. The bottom also has another 3 edges. Notice that we can't count those edges on the rectangles anymore. So we have 6 edges so far, and we just have 3 more edges on the vertical sides of those rectangles. So 3 plus 3 plus 3 is 9 edges. So we have a total of 5 faces. There are 2 base faces and 3 lateral faces. We have 9 edges. The base shape is a triangle shape, and there are 2 of them. And then hopefully from our last section on volume, you recognize this as a triangular prism because the base shape is a triangle. So we have a few different types of prisms. We could have rectangle prisms, we could have triangular prisms, and we could have cubes, which are just square prisms. Those are the 3 main ones that we'll be practicing, although you could have really any type of prism. You could have hexagonal prisms, octagonal prisms, and so on. We're not going to get into those, though. All right, now let's talk about how to find the surface area of a prism. When we talk about surface area, there's actually 2 types of surface area. There is a total surface area, which simply means just add up all the areas of all of the surface or all of the faces, and that would give us our total surface area. If we subtract the base area, if we have a top and a bottom base, and that just leaves the lateral areas, well then that's the lateral surface area. So the lateral surface area will be the surface area minus the base areas. Or just don't include them if you're just adding up your areas. The reason why we have two different types is sometimes we have shapes that don't have a top, and so we can't include all of the base shapes. Sometimes the lateral surface area is a way of representing the total surface area of the shape because it doesn't have bases. Other times it is a closed figure and it will have bases. So we'll practice both. Here's the formula for surface area of a prism. To find the lateral surface area, the shortcut is just to find the perimeter of the base and multiply that total perimeter by the height of your prism. Certainly much faster than taking the shape apart and looking at the net, but I'll do both just to show you that they're the same. To find the total surface area, sometimes just simply called surface area, make sure that you take that lateral surface area and add in two of your base areas, because there should be a top and a bottom. So we'll find the base area and we'll just double it. One way to think about surface area is how much paint you would need to cover all of the surfaces of these shapes. Another way to think about it is how much wrapping paper would you need to cover all of the surfaces of these shapes. So that's what we're doing here in this example. Trying to find the least amount of paper needed to wrap the gifts. Well, another way to say this is find the exact amount of wrapping paper needed. But oftentimes when you're using wrapping paper, you're not measuring, and most times you're actually overestimating the amount you need and doing some folds, right? But here we're just going to find the exact surface area. So like I said, we can do it two different ways. We can think about the net area, so I could unwrap this shape. When I use my net areas, I like to label my pieces. That way, if I made a mistake, I can always go back and just go back to the piece that I may have mislabeled or miscalculated. If you don't label them, then after a bunch of steps, going back to check and find a mistake may be a little bit difficult, and you don't want to waste all of the time that you used building this without labeling it. So I have a top rectangle here. The dimensions of my top rectangle are 9 by 5. So the area of the top piece, or one of my bases, is 9 times 5, or 45. Because the top and the bottom of this prism are the exact same rectangle, I can just double one of my base areas to get my double base area. So 45 times 2 is 90. So the base area is 90 square centimeters. Sorry, double the base area is 90 square centimeters. If I unwrap the sides, or the lateral pieces, the lateral faces, well, I have this front rectangle closest to me. That's a 9 by 14 rectangle. The back, right behind it, is actually the exact same rectangle. So if I find the area of 1, I can just double it. So 9 times 14 times 2 gives me 252 square centimeters. That's the area of the front and the back. Still have two more rectangles. I got the left side, I'm going to call it LS. That has a width of 5 and a length of 14, so 5 by 14 there. The right side is the exact same rectangle, same dimensions, 5 by 14. So let's find the area of 1 and double it. 5 times 14 times 2 is 140 square centimeters. So now I have everything I need to find the total surface area. I have my lateral surface area. That was the area of the side rectangles, the front, back, left, and right piece. So if I take the front and the back, 252, and the left and the right, 140, combine those, that gives me my lateral surface area. The surface area that does not include the base areas. So that's 392 square centimeters. To find the total surface area, I just need to take that value and add in double my base area, which I already found was 90. So 392 plus 90 is going to give me 482 square centimeters. That's the total amount of paper I would need to wrap this rectangular prism exactly. All right, so there's a rectangular prism. Somewhat simpler than other prisms because some of your faces are the exact same. When we get to a triangular prism, it could be a little bit trickier. One of the hiccups is that you may only be given two sides of your triangle. And notice that right here, the top of this rectangle, that length is not given. That's something that we need. So we'll get to that in a minute. In order to find the area of the triangle, though, we don't need that hypotenuse length. We just need those perpendicular sides, the base and the height of our triangle. So 12 times 16, cut that in half. That's the area of my triangle. So that turns into 96 square inches. If I double that, because I have a top triangle and a bottom triangle that are the exact same, 96 times 2 is 192 square inches. So there's double my base area. Now what I need to find is my lateral surface area. So that would be the area of the rectangles that go around the shape. The left side, this left rectangle, I have the dimensions. I have a height of 18 and a length of 12. So 12 times 18 gives me the area of that left rectangle. That's 216. The right side also has the dimensions I need. It's got 16 by 18, so if I multiply those two dimensions, I get the area of the right rectangle. That's 288. But this front rectangle, I need to do some extra steps with. I need this length right here because I have the height of 18. So let's go back and look at the triangle. It's a right triangle, so that's helpful because if we know 2 out of 3 sides in a right triangle, we can use the Pythagorean theorem to find the hypotenuse, or really any third side. To find the hypotenuse, though, specifically, we're going to take the sum of the square of the two legs. So 12 squared and 16 squared, add that together, and then square root it to solve, and we get 20. So now I have the dimensions to find that front rectangle area, 20 by 18. 20 times 18 is 360. Now I have the three areas needed for my lateral surface area. I have 216 plus 360 plus 288. So that adds up to a total of 864 square inches. To find the total surface area, I just need to take that lateral area and add in those two base areas. So let's take 864 and let's add double our base areas, or 192. And we get 1,056 square inches. All right, so using the net is an awful lot of work, an awful lot of steps, and there's plenty of room for error if you just mistakenly write the wrong unit or identify it incorrectly. So this formula right here, perimeter of the base times the height, simplifies things a lot. You can see here how much work was needed for the net compared to how much work I need to show just using that formula. So let's try using the formula instead as a shortcut. And if you understand the nets and understand that surface area is really just the area of all of the two-dimensional shapes as you go around the figure, then you're allowed to use the formula and take the shortcut. So we need the perimeter of the base. We know the base is either the top or the bottom rectangle here. The perimeter would be 9 plus 5 plus 9 plus 5, or 9 plus 5 doubled. And the height is 14. So 9 plus 5 is 14, doubled is 28. 28 times 14 is also 392. So way easier, way faster. Let's do that one more time over here on the triangular prism. To find the perimeter of our triangle, we did still have to use the Pythagorean theorem to find that hypotenuse, because we got to know all three sides to find the perimeter. So 12 plus 16 plus 20 is the perimeter. Multiply it by the height of your prism, 18. So 12 plus 16 plus 20, that should be 48 times 18. should be equal to 864. So much less work, much faster to do it that way. You choose however you want to practice. The practice worksheet will give you plenty to use. Let me know if you got questions on how to find the surface area of a prism.